hello everyone. We have this equation here, which is y is equal to x cubed plus 3x squared minus 4. So for this equation, we are asked to find the critical points. So in order to find the critical points is we need to derive this equation. So the derivative of this equation is y prime is equivalent to 3x squared plus 6x. And after getting the derivative, we're going to need to equate it equal to 0. And after equating it to 0, we're going to be able to get the x point. And by using the means of calculator, we're going to input the coefficients, which is 3, 6, and 0. And then we'll be able to get the first x, which is negative 2, and second x, which is 0. And after being able to get the x's, we're going to need to find its corresponding y. So in order to find its corresponding y is we're going to substitute the x's to the original equation. And we're going to substitute it. So we're going to substitute the first x, which is the negative 2. So negative 2 in the first equation. So our y is now 0. So for the second one, we're going to use 0. Calculate 0. So it will be our second y will be negative 4. Negative 4. And after getting the critical points, we're going to need to find we're going to make a number line in order to determine which is the maximum and the minimum, and also the domains in the critical points. So in order to make the number line, we're going to arrange the points from the least to the greatest. So as we can see, the negative 2 is less than 0. So we're going to put it in the left side and 0 on the right side. So in order to determine its domains, we're going to need to find a value which is less than negative 2 and a value that is in between negative 2 and 0, and a value that is greater than 0. So for this problems, we're going to use negative 3 for the least amount of negative 2, and for the middle, or in the value in between, is negative 1, and for the value that is greater than 0 is 1. So what are we going to do with this value? So this value will help us to determine the domain of the critical point. So after deciding what value you're going to use, is you're just going to substitute it to the derived equation. So you're going to use the calculator again. So since we decided that we're going to use negative 3 as a value that is less than negative 2, so we're going to substitute negative 3 to the derived equation. So negative 3. So we get 9. Since 9 is a positive, so we're going to write positive on the left side of negative 2. So since we decided that the value in between negative 2 and 0 is negative 1, so we're going to substitute negative 1 to the derived equation, and we'll be getting negative 3. Since it's negative, so we're going to put negative sign in between. And for the value that is greater than 0 is, we decided to use 1, so we're going to substitute 1, and we're going to be able to get 9. Since it's positive, so we're going to write positive. So from this, we can determine now the domain. So it states here that whenever x is less than negative 2, it is increasing because it shows positive sign. And for the second one, which is negative 2, is if x is greater than negative 2 and less than 0, or which is in the middle, it is decreasing. And if x is greater than 0, it is increasing, which is positive. So this will help us in determining the graph and the maximum and minimum of the said equation. So after being able to find the number line, we're going to need to find the x-intercepts. So after getting the we need to find the x-intercepts. So we're going to use the original equation. So in order to find the x-intercept, we're going to substitute all y to 0. And so we did substitute all y to 0. And after, we're going to find the x's, which are the x is equal to 1, and the second x is equal to negative 2. So for the y-intercept, to find the y-intercept, we're going to substitute all x's to 0. So after substituting all x's to 0, we are left with negative 4, which is our y-intercept. So after being able to get all the points, which is the critical points and the intercepts, we're going to need to plot it now in a graph. So our graph should look like this. Since the critical point, which is negative 2 and 0, here is negative 2 and 0, and the second critical point is 0 and negative 4. Here is 0 and negative 4, and the x-intercept is 1. It is understandable that the y is 0. So 1 is equal 1 0 is here, and negative 2 0 is same with the critical point, and the negative 4. This is understandable as that the x is 0, so it is 0 negative 4. So it is the same, also the same with our critical point. So your graph should look like this. So this is where the number line comes in, or the domain that we had earlier. So it is said that before reaching negative 2, it is increasing. So as you can see, it increases as it touches to the negative 2 point, and in the middle of the 2 points, it decreases. It goes down, and after it increases. And then we can now determine that the maximum is the negative 2 0, and the minimum is 0 negative 4.